Hi everyone, this is our chapter 6 HL test review, and this is the second question. In the second question, the first part asks us to integrate sine theta over 1 minus cosine theta. And when we integrate a function, we need to try to find the antiderivative of that function. The first thing I notice is that the derivative of cosine theta equals negative sine theta, which means the antiderivative of sine theta, once I move this negative over, equals negative cosine theta. Right. Now, remember that we have to add a constant over here because the derivative of the constant is 0. And so if the antiderivative of sine theta equals negative cosine theta, it also equals negative cosine theta plus 2 because the derivative of negative cosine theta plus 2 is sine theta plus 0. Which means that it's also same negative cosine theta plus 17 or negative cosine theta plus 1. And when we rewrite negative cosine theta plus 1, we get negative 1 minus cosine theta, which is what we just have right here, or what we just have right there. So, we know that the derivative of negative cosine theta plus 1 equals sine theta. Which means now we can use U substitution. And I'm going to show you how we do that. So I'm going to let U equal 1 minus cosine theta. And when I rewrite my equation, sine theta is the derivative of 1 minus cosine theta. That's just the U over d theta. Over 1 minus cosine theta, which is U, times d theta. And that equals the integration of du over d theta times d theta, which cancels out. So that's just du over u, which equals 1 over u du. Now, now we're going to try to find the antiderivative of the 1 over u. Remember, that can be written as u to the negative 1 du. And remember that the antiderivative of u to the negative 1, or u to the 1 power, that's just e. So that equals e. Sorry, my bad. The antiderivative of u to the negative 1 power equals, that is ln u. Alright? Ln u, and remember we always have to add a constant again. So, that's our integration. Now we have to plug in 1 minus cosine theta back into u. And so we get ln 1 minus cosine theta plus c as our integration. Okay, now the second part of this question tells us that given that the integration from pi over 2 to a of sine theta over 1 minus cosine theta d theta equals 1/2, and pi over 2 is less than a and a is less than pi, find the value of a. Well, we see the integration here. This was what we just had solved, right? So the integration of pi over 2 to a of sine theta over 1 minus cosine theta is just, the antiderivative of that is what we found, ln 1 minus cosine theta plus c from from pi over 2 to a. That equals 1/2. Alright, so let's do the second part. We know that A is between pi and pi over 2. So our angle should look something like this. It would be an obtuse angle. Alright. Now I'm going to plug these two constants in, or these two variables in to theta. That gives us Ln natural log of 1 minus cosine A plus C minus natural log of 1 minus cosine pi over 2 plus C. That gives us the natural log of 1 minus cosine A plus C, but minus C over here, so that cancels out, minus the natural log of 1 minus cosine pi over 2. And that equals 1 over 2, remember? So I know the cosine of pi over 2 is just 0. Therefore, 1 over 2 equals the natural log of 1 minus cosine A minus the natural log of 1 minus 0, which is the natural log of 1. That gives us the natural log of 1 minus cosine A, and the natural log of 1 is just 0, because anything e to the power of 0 equals 1. So that gives us 1 over 2 equals the natural log of 1 minus cosine A. Now, if we do I heart logs and stuff like that, we get e to the 1/2 equals 1 minus cosine A. Therefore, cosine A equals 1 minus e to the 1/2. And when we solve that, A would equal the inverse cosine of 1 minus e to the 1/2. And when we solve that, that gives us around 2.28 as our answer. And to verify that, if we just change this back into radians format, that is greater than pi over 2, which is around 1.7, and that is less than pi, which is 3.14. Oh no, my bad. This isn't 1.7. This is more like I don't remember. Yeah, but it is between pi over 2 and pi. That is our answer for